chapter 3. We are going to talk about Ohm's law, power and energy or work. A little review here. We defined in chapter 2 what was voltage, we defined what was current, and we defined what was resistance. Now we are going to introduce Ohm's law, which is a fundamental law in electronic analysis. It basically describes mathematically how voltage, current, and resistance are all related. So we have the definition of Ohm's law as I equals voltage over resistance, where I is in amperes, B is in volts, and R is in ohms. It's just a plug-in formula. It's a first order formula, so we have to have two knowns in order to find the third unknown. Otherwise, it is not solvable. There are different representations for the Ohm's law. We can have it B equals to I, current times resistance. We can have it as R equals voltage over current, or we can have the current is equals to voltage over resistance. Depending what is the quantity that we are looking for, we can use either of these three representations, which is the same, it just solved for a different quantity. Ohm's law also states that current and voltage are directly proportional and that current and resistance are inversely proportional, and we can see that in case number 1 we keep resistance constant and we just vary the voltage and the current, and we see that as we increase the current, the voltage increases, and as we decrease the current decreases. Case number 2, now voltage is constant, so we see that the inverse proportional with resistance as follows. If the current decreases, it's because the resistance increases. If the resistance decreases, then the current increases. And this is just the math explains it, because we have the R at the denominator, so that's how it's inversely proportionality right there. Keep in mind that I, it is in amperes, B is in volts, and R is in ohms. Here they solve for voltage, and they are saying use Ohm's law to solve for voltage, given that you have the current and you have the resistance. Be very mindful and be careful with the milliamps. That means 26.5 times 10 to the negative 3 amperes. You plug in here and then you should get 18 volts. Ohm's law, they are giving us another example for a different representation when they are solving for R. So right here they are saying that the amp meter is measuring 0.87 amps, and you are calculating what is the resistance on the of the light bulb. They are giving us that the outlet is producing 115 volts, so we just put 115 volts divided by 0.87 to get 132 ohms. Just another representation of Ohm's law. Right here, something very interesting here. We can find the resistance by finding the slope of the IV curve. We have voltage in the x-axis and current in the y-axis. So how do we do this? If this is given, this is for a lab setting where we don't know the resistance of the box, but we can know how much power or how much voltage we can put into the box, into the system, and we can read how much current are we getting on the other side of the system. So this will be this scenario where we don't know what is inside the box, but we can calculate what is the equivalent resistance to it. So how do we do that? So we have the table that was generated by measurements by a lab, and then we can find the slope. In order to find the slope, we have to pick 2 points along the curve. As we can see, it is a positive slope, so that makes sense because resistance is a positive value. So we pick 2 values. It doesn't matter where, because the slope of a curve is the same regardless or independent of where you choose it or where you pick the points. So right here, pick 2 points. For simplicity, I chose the origin, which is 0, 0, and then I chose this other point right here. Could I choose any other point and the solution should be the same? So X and Y. So for X, which is my voltage, I'm going to choose here, which is 5 volts. And then for my Y, I chose this point, which I calculated to be 1.8 milli. The units, be very careful with the units, is giving us milliamps. So then I write the definition of a slope, which is rise over run. I just plug in my rise is just my Y value, which is 1.8 times 10 to the negative 3, divided by my run, which is my X value, which is 5, and I get 0.36 times 10 to the negative 3. I'm just using my laws of exponent here, okay? So, but let's look at this. The resistance is defined using Ohm's law as voltage over current. If I do this rise, what is the rise? Is current, and the run, it is voltage. So I have current over voltage, which is exactly opposite to here. So what is this definition? This is defining, if I just find the slope, what I'm finding is the conductance. I'm just finding conductance. And what is conductance? Conductance is defined as 1 over resistance is defined as 1 over conductance. So if I do 1 over that value, I'm going to find my resistance value from this graph right here. So I do 1 over 0.36 and I get 2.77 times 10 to the 3, which is equals to 2.7 kilo ohms. Very important here. Be mindful of the definition of a slope. Be mindful of the units in which you're working, and then know that if you're asked for resistance, you cannot stop right after the slope. You have to do 1 over the slope so that you can actually find the voltage, the resistance value. Okay, so let's move on. That was actually that example that we just did. I just wrote it down there for you. So okay, it's the same example that we just did. I was just wondering why they have it twice, but I think they just have the conductance there and then they say the reciprocal. Okay, that's actually a different example. They are actually going from in increments of 2. Okay, so the one we did was this one, but if you can try this, it's the same. The answer is there, so you can practice on your own. Okay, now here is another important characteristic that we have. This is for lab. Remember, it is okay when we are designing, we can control all the parameters, but most of the cases, what we are giving is something that is already designed and we have to go and modify it. So a lot of the information, we don't know it, so we have to know how to find it. So in these ways, we have a curve that represents current versus resistance, and they are asking you, what does this mean? So what in this case means is that you keep varying the resistance or the resistor value, and you keep varying the current value, or you keep taking measurements as long as you keep the voltage constant. Remember, you can only be varying one thing and measure the other thing so that you can see the effect. So in this case, we can be modifying or changing the resistance, measuring the current as long as the voltage is constant. Or we can be modifying the current, measuring the resistance, but the voltage has to be constant. So how do they do that? So once this graph is generated, let's say I don't know what the voltage is, I just keep modifying the resistance. So how do we do that? So in order to do that, we go here. We know the definition of resistance with voltage over current, and then I said that voltage is equals to current time resistance. So I can pick any two values. And any of the two values that I pick, they have to give me the constant value voltage that I have kept during my testing points. So if I choose this point, for example, if I choose this point where I have current to be 6 and resistance to be 2, keep and be mindful of the units. I have kilo and I have milliohms right here. So if I go here, I have 0.5 kilo ohms for my resistance, and I have 6 times 10 to the negative 3 for my current. So the kilo and the milli cancel, so I get 3 volts. I can pick another point. Let's go back and pick another point. I can pick this point right here. 2 for current and 1.5 for resistance. So in that case, I'm going to have 1.5 kilo ohms for resistance and 2 milliamps for current. So if I multiply them, I get again 3 volts. And that makes sense. The 3 volts should be all across.